Alright, hey, this is lesson 8 of Unit 2 Topic 1, and we're going to look more into functions because that's what this topic is all about. And in this case, we're going to be looking at graphs and how graphs can match scenarios that are given. Alright, so this starts off with a warm-up, which is having us graph both linear and exponential functions. So what they're given is just a graph where there's no axes. So the first thing I'm going to do is I'm going to make a x and a y axis. There's my y-axis and there's my x-axis. And what this is saying is that it's starting at 5, 1, 2, 3, 4, 5, 0, 5. And then 1 in this case would be a decrease of negative 2 once, down 2. The next number would be 2 below, which would be negative 3. And the second number would be at negative 1. And the next number, I'm sorry, positive. Sorry, I don't know why I'm thinking negative yet. We're still above the line. So this one is 3. This one's 1. Now it's negative 1. Third number is down here. All right, so that would be what the equation looks like. So basically what it's saying is that it starts at 5 and it decreases by 2 per number. Same thing here. It starts at 4. So we know it's going to be 0, 4, and it's going to decrease by 3 per number after that. So the first number is going to be 1. The second number is going to be negative 2. And then the third number is going to be negative 5. Now if I know that, now I can set up my axes correctly. There's my y. And let's make it pretty high. Let's go up here. 0, 1, 2, 3, 4 would be perfect right there. 1, 1, 2, negative 2, and 3, negative 5. All right, so once again, that's going to be a linear function. It's an arithmetic sequence. It's decreasing at a steady, constant rate. These are not decreasing at a steady, constant rate. The first number is, the starting point happens to be 5. And every number after that is going to be triple. So the first number is going to be 15. The second number is going to be triple that, which happens to be 45. And I'm going to stop right there because you can't even graph those. All right, so I'm going to make a quadrant that looks like this. I'm going to make a single quadrant, not Cartesian graph. Or you can make it like that, whatever. All right, so there's my x and my y axis. 0, 1, 2, 3, 4, 5. So it's actually going to look something like this. And it's kind of hard for me to even graph that. I should have made my increments go by 5. I should have said 5, 10, 15, 20, but it's a little late now. All right, this graph over here is going to start at 4, and I know that because that's the starting point out there. And the next number is going to be twice that. So that's going to be 8, and that's going to be 16. All you got to do is look at the function. This means starts at 5, and it triples each time. Starts at 4, doubles each time. All right, I'm going to do the exact same thing, make my axes like this. 0, 4 would be 1, 2, 3, 4 up here, sorry. 1, 8, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to show you how to put this in the calculator, and it's going to look something like that. All right, so there's the warm-up, and let's keep it going to the lesson. So in the lesson, the first thing it has you do is take the given stuff in the scenario and put them in the order that you think it belongs in. So in this case, you can read the story yourself. It's about the series. Sylvia wants to fill up her pool and play in it and then empty it. And we want to show how much water was in the pool over time. Started off with nothing. She filled the pool with a hose. So let's say she filled it. It went up. And then I'm going to stop right here because then her and her friends played. So she filled it up. Then they played, which isn't one of the activities. And then they're going to use the draining hose, which is going to decrease at the same rate that the other one increased. But the problem is when you use a hose, you can only get so much water out. You can't get all of it. So then they're going to use the buckets. So they drained it out with a hose, and 2 of her friends are going to help her. Actually, let's say she started using a bucket by herself. Using a bucket, and then her friends helped, which is going to make it go down even faster. All right, and then she cleaned the empty pools. Oh, well, I could have said she took a break. Maybe this was taking the break right there, but I think of that as also swimming in the pool. All right, so now we're going to do some matching. We're going to match the words to the graph. And this is really what you're expected to do by the end of this lesson. Some of these can be very, very tricky, so you got to be careful. The speed at which a person climbs up the steps of a high slide at the community and then slides down. So you always, in all of these, need to identify what are the 2 variables. Then we're talking about speed versus height, in which a person climbs up the steps of a high slide at the community and then slides down. So we're talking about speed in this case. Speed over time. I'm sorry, I said height. So we're looking for something that shows speed as they climb up a high slide. So typically when you go up a high slide and then slide down, your speed in the beginning is going to be quite slow. And then when you get to the top of the slide, you're actually going to stop at the top of the slide, and then you're going to slide down. All right, so that one is actually this graph. And this is my favorite question of them all. So this is you climbing up the steps. At the very beginning, you're going slow because you're just starting to climb, and then you start climbing at a kind of a constant rate. And then you're going to slow down because you're getting to the top of the slide. And then this is my favorite part right here. You're going to slide down the slide, because when you slide down a slide, what happens to your speed? Your speed increases. This is sliding down the slide. And then when you get to the bottom of the slide, you're gonna very quickly slow down your speed until it comes to a stop. So this is the one that actually shows sliding down the slide. So that would be letter G. The number of full soda cans left at the time the party started until the end of the party. Now, this is kind of a giveaway. This is full soda cans. Can you have half a full soda can? No, you cannot. So you know it's going to have to be discrete. It's got to be one of these two right here. This one's, we'll talk about this one. It's kind of a version of discrete. And it's this one. So the amount of soda cans, so somebody took a soda can, took a soda can, took a soda can, and so forth. So that one's definitely F. And the fact that it's a discrete question kind of gave that away. The height of a ball, so we're talking about the height of a ball. After it was time to throw up. Okay, into the air until it lands to the ground. So the height of the ball when it starts to be thrown, it would be, right here where you're holding it and throwing it. You throw it up into the air, and its height increases, and over time it's going to fall down to the ground because of gravity. So that's definitely letter D. The speed of a train pulling into a station right until it brakes. Okay. The speed of a train until it brakes. Well, it can't be a negative speed. It can't be a negative speed, so we definitely know that. It's not going to be increasing because when it comes to a stop, it's slowing down. So I'm going to guess that it's letter H. Not quite sure why it would be increasing to begin with. I guess maybe they thought they had to give it some gas before they got into the train station. I'm not quite sure, but H is looking like the one that is the most appropriate. You're definitely going to decrease your speed at a constant rate, so it's definitely not going to be discrete. The temperature of a turkey in degrees Celsius from the time it's removed from the oven, served, and its leftovers are freezed. That looks like C, because it's pulled out of the oven, it's getting cooler pretty quickly, then it's about room temperature, then you put it in the freezer, and its temperature is going to decrease rapidly. So that's going to be letter C. The amount of earned by a person who gets paid per hour. Well, you don't get paid for half an hour. You're going to get paid the same amount of money. So if you work 1 hour, you get paid this amount of money. If you work 2 hours, you get paid this amount of money. So that's definitely going to be the letter E. Question 7, the speed of a cross-country runner from the time they begin the race to the time they cross the finish line. So we're talking about speed here. And what graphs do we have left? So I'm thinking A, maybe. A, they start off stopped, and they pick up the speed, keep it at a constant rate. Maybe they get tired, so they dip a little bit, and then they get to the very end of the race, so they figure, you know what, I'm going to give it my all, and I'm going to sprint at the end. So there's A. Profit over time from a business as with startup costs. Well, startup costs means that you get to spend money before you've made any money, which means you actually owe money in the beginning with. And it takes you a while. You have to sell some stuff in order just to get back to break the even. And then I'm not quite sure what happened right here, but a business took a dive for some reason and then they started making money again. Maybe they bought more supplies, and that's what caused it to go down. So that one is definitely letter B. All right, so I've given my justifications on each, and that's basically, so it looks like we have a quiz this day. Your homework is going to be the exact same thing, and then this got cut off, so I'm going to have to kind of look at my own at the same time. Let's look at the context and then try to match it with which graph we think matches it. The amount of money of a savings account where regular deposits and some withdrawals are made. So that is a discrete amount. That is a discrete question because you can't continuously put money in the bank account. It's going to go up and down in discrete fashion, and that looks like letter D. D is going up, and then it's going down for withdrawals, and then it's going back up for deposits again. So once you press money, it's going to stay at that amount for a little bit of time. And then you put another deposit, it's going to stay at that amount for a little bit amount of time. The temperature of an oven So we can cross that off. The temperature of an oven on a day that mom bakes several batches of cookies. Well, every time you open up the oven, it's going to decrease the temperature. So it's going to increase when it's shut, and it's going to decrease when it's being opened. So my guess is that that's going to be A, because that's the only one that's going up and down at a constant rate. It's never stopping. It's not discrete. The amount of gasoline on hand of the gas station before tanker trucker delivers more gas. The amount of gasoline on hand at the gas station before the tanker truck delivers more. All right, so the amount of gas at the gas station is going to decrease. That's the one that got cut off down here. If you're looking at your paper, though, that's the one that's decreasing at a constant rate. It's not a constant rate, I'm sorry. It goes down, it dips, because as a person takes gas, it takes out a lot of gas in a short amount of time, but then nobody takes gas. So it's going to go down when a person takes gas and then level off. And then down when somebody takes away more gas and then level off. The number of watermelons available for sale at the farmer's market, that's a discrete, because you can't have half a watermelon. That one is definitely C, because that's the only discrete question left. It's never going to increase because they don't get more watermelons. It's going to go down the entire time. Now, just by the process of elimination, I think this one has to be B. Let's make sure. The amount of mileage recorded, that has to go up the entire time, on the odometer of a delivery truck over a period of time. So it looks like they drove, and, maybe they sped. I don't know what happened here. Then they drove slowly, and then they sped. Drove slowly, and then sped. So that's going to be B. B is going to be the best answer there. All right, that looks like that concludes lesson number 7 or 8. No, this is lesson 8, isn't it? Yes, it is. All right, thanks for watching.